So in today's video, we're going to go ahead and briefly cover the integral of sine hyperbolic of x and cosine hyperbolic of x. And so as a little bit of a review, if you aren't really familiar with these two functions, cosine hyperbolic of x is given by 1/2 e to the x plus e to the negative x. And similarly, sine hyperbolic of x is given by 1/2 e to the x minus e to the negative x. So here the only difference is that we have a negative sign over there. And so these two functions have a very nice property where the derivative of sine hyperbolic of x is just cosine hyperbolic of x, and then the derivative of cosine hyperbolic is just sine hyperbolic. And so as a result, when we're taking the integral, we can just determine quickly that the integral of cosine hyperbolic of x dx is just equal to sine hyperbolic of x plus c, and then the integral of sine hyperbolic of x dx is equal to cosine hyperbolic of x and then plus c. And so we're just going to go ahead and quickly apply these. Later on, we may actually do a little proof, but I mean, frankly, if you kind of just look at the fact that the derivative of sine hyperbolic is cosine hyperbolic and the derivative of cosine is sine hyperbolic, then it is very easy to determine these two definite or indefinite integrals over here. So let's go ahead and cover a couple of quick examples. So first of all, we're taking the indefinite integral of 2 cosine hyperbolic of x dx. And so this 2 right over here is just going to be a scalar, so we don't really have to think about it. And then we just have to remember that the integral of cosine hyperbolic is sine hyperbolic, and then we just end up with 2 sine hyperbolic of x plus c. And that's our final answer right over there. And then next up over here, we have the indefinite integral of negative 1/3 sine hyperbolic of x. Again, this negative 1/3 over here is just a scalar. The integral of sine hyperbolic is cosine hyperbolic, and then we get negative 1/3 cosine hyperbolic of x, and then plus c. And so those two are pretty easy. Now we have this one over here, the definite integral from 0 to the natural log of 7 of 1/6 times e to the x plus e to the negative x. So this one we just have to do a little bit of manipulation. We have to, first of all, we can just recognize over here that this e to the x plus e to the negative x looks very similar to the formula of cosine hyperbolic. And so let's go ahead and just rewrite this as the integral from 0 to the natural log of 7. And then over here we have a 1/6, but what we really want is just a 1/2. And so what we can do is we can express this 1/6 as 1/3 times 1/2, right? Because this is basically just 1/6 when you multiply this out, okay? And then we just have e to the x plus e to the negative x, and then dx. And so now over here we have this 1/3, the scaling factor. We have this 1/2 times e to the x plus e to the negative x. And so this right over here, we can go ahead and just rewrite that as cosine hyperbolic of x, and then we simply get the integral from 0 to ln of 7 of 1/3 cosine hyperbolic of x dx. And then we just have some simple integration. So again, we can just keep that 1/3 out of here if we would like. The integral of cosine hyperbolic is sine hyperbolic, and we don't need to include the plus c because it's a definite integral. The natural log of 7 to 0, and then let's just evaluate this. So 1/3 sine hyperbolic of ln of 7, we just have to rewrite that as e to the ln of 7, and then that's going to be minus e to the negative ln of 7, and then all of that over 2, right? And then we can just go ahead, we can keep this 1/3 out of here if we want. We can subtract e to the 0 minus e to the negative 0 over 2. And then this right over here, e to the 0 is 1, e to the negative 0 is also 1, and so this entire term is just 1 minus 1 over 2, and so this entire thing just becomes 0. And then over here we have e to the ln of 7, which we know is just going to be 7, e to the negative ln of 7, that's going to be 1/7, and so this just becomes, we can take this 2 out, we get 1/6 times 7 minus 1/7, we get 1/6 times, this is going to be what, that's 49 minus 1/7, which is, what is that? That's 48/7 times 6, and we can just go ahead and we can simplify that if we would like. We would get 16/7 times 2, right? So 16/14, but 16 and 2 cancel out, so we get 8/7 as our final answer. I'm hoping I didn't screw that up somewhere in the calculation. But that would be our final answer. And essentially all we have to do is we just have to recognize where we can spot, this pattern of e to the x and e to the negative x in order to obtain cosine hyperbolic or sine hyperbolic, and then that makes the integration process much, much easier.